The objective for this video is to learn how to conduct a hypothesis test about the significance of the linear relationship between two variables using the p-value method. The table shows the relationship for 17 randomly selected students between the number of hours spent studying per week and the student's GPA. The graph shows the scatter plot for this correlated data. This graph shows a positive linear relationship. For this relationship, the sample correlation coefficient R is 0.864. Recall that the closer the value of R is to positive 1, the stronger the positive linear relationship between the variables. The closer the value of R is to negative 1, the stronger the negative relationship between the variables. And the closer the value of R is to 0, the weaker the linear relationship between the variables. The Greek symbol rho is used to represent the population correlation coefficient. The lowercase letter r is used to represent the sample correlation coefficient that is used to estimate rho. If rho is equal to 0, then there is no relationship between the variables. We must use a hypothesis test about whether the value of r is high enough if we are to conclude that there is a significant linear relationship between the variables. There are 4 assumptions for testing the significance of the linear correlation coefficient. 1. The data are quantitative and are obtained from a simple random sample. 2. The scatter plot shows that the data are approximately linear related. 3. There are no outliers in the data. 4. The variables x and y must come from normally distributed populations. In a previous video, we used the critical value and test value method for testing the significance of the linear relationship for these variables. This test can also be conducted using the p-value method. The method is the same as the p-value method exhibited in the videos for chapters 8 and 9. Alpha equal to 0.05 is very commonly used as a level of significance in this type of test and is what we will use for this example. The null hypothesis will be that rho is equal to 0. The alternative hypothesis will be that rho is not equal to 0. If we reject the null hypothesis, then we will conclude that a significant linear relationship exists between the variables. We will use the TI graphing calculator to calculate the p-value for this hypothesis test. We will begin by pressing Stat and then 1 in order to enter the list editor. Now enter the data for the hours spent studying per week in list 1 and the corresponding GPA values in list 2. Now press Stat, cursor over to Tests, then cursor down until you find the linear regression t-test. Highlight that selection and then press Enter. Make sure again that the X list is set to L1 and the Y list is set to L2. We need to make sure that the next line is set to match the alternative hypothesis. So we need to highlight rho not equal to 0 and press Enter. The p-value is given as 7.88 times 10 to the negative 6. In decimal form, this would be expressed as 0.0000788. P-values are typically expressed with 4 decimal places. In this case, the p-value has 5 zeros past the decimal place before a non-zero digit is encountered. Recall that the decision rule when using a p-value tells us that if the p-value is less than alpha, we should reject the null hypothesis. Since this p-value is less than 0.05, we should reject the null hypothesis. Since we have rejected the null hypothesis that the population correlation coefficient is equal to 0, we conclude that it is not 0. Therefore, we conclude that there is a significant linear relationship between hours spent studying and GPA. In this video, we learned how to conduct a hypothesis test about the significance of the linear relationship between two variables using the p-value method.